You know, whenever we look up at the night sky, it's almost impossible not to wonder if anyone is looking back at us. We live in a universe filled with hundreds of billions of galaxies, and each of those galaxies contains hundreds of billions of stars. It's mind-bogglingly huge. But today, in this explainer, we're opening up what is literally the ultimate cosmic cold case. We're asking a question that has haunted scientists, philosophers, and sci-fi writers for decades. And trust me, the answers we're going to explore today, they range from deeply profound to absolutely terrifying. So let's get into it. Okay, let's dive right into this. If the universe is teeming with life, where is everybody? That single sentence right there, it captures a staggering, almost maddening contradiction. Think about it. We know the basic building blocks for life are everywhere. We also know the universe is incredibly, incredibly old. So if you just run the numbers, mathematically speaking, the cosmos should be a bustling metropolis. It should be packed with civilizations. And yet, when we point our telescopes at the stars and listen, we hear nothing. Just a deafening, empty silence. To really understand how scientists first started tackling this eerie silence, we have to travel back in time a bit to November 1961. Picture this, a highly exclusive, super informal gathering of some of the greatest minds of the era, all meeting up at the Green Bank Observatory. I mean, just imagine the sheer brain power in this room. You had legendary planetary astronomer Carl Sagan, physicist Philip Morrison, and biochemist Melvin Calvin. Actually, fun fact about Calvin, he literally got a phone call right in the middle of this very meeting to tell him he had just won the Nobel Prize. Seriously, no big deal, right? Anyway, this brilliant group of guys basically sat down and formally laid the groundwork for what we now know as SETI, the search for extraterrestrial intelligence. But there was this massive shadow hanging over their research back then, and honestly, it still hangs over all of our research today. It's called the Fermi Paradox. Very simply, it's the intense contradiction between the ridiculously high probability of alien life existing and the fact that we have absolutely zero evidence of it. None. Nada. Our galaxy is roughly 10 billion years old. Even if you factor in relatively slow space travel, any advanced species out there would have had more than enough time to spread out and leave some kind of footprint for us to find. But recently, researchers have started poking holes in the very foundation of this paradox. They're pointing out a potential massive flaw. You see, the entire Fermi paradox relies heavily on one huge underlying assumption. The idea that once an intelligent civilization develops space travel, they're just going to inevitably keep expanding exponentially. We assume they'll just jump from star system to star system endlessly without ever hitting the brakes. And why do we assume that? Well, mostly because that's exactly what human populations have historically done here on Earth. Let's move along and see how this logic actually builds out in practice. The whole idea of exponential expansion relies on a concept we can call the spatial expansion loop. It's basically a treadmill. It starts when a civilization faces a resource shortage. That shortage forces the population to migrate out to new, totally uninhabited regions. Suddenly, they hit a jackpot, a resource surplus in this new area. That surplus fuels a massive population boom, which, you guessed it, eventually causes another resource shortage, and the cycle just repeats, pushing the civilization further and further outward into the cosmos. Now, if an alien civilization actually followed this exact loop, spreading out, establishing colonies, and then those colonies send out even more colonies, the math happens incredibly fast. Even if they're only traveling at a tiny fraction of the speed of light, an intelligent species could realistically traverse and colonize the entire Milky Way galaxy in roughly 1 to 100 million years. I know a million years sounds like forever to us, but cosmologically speaking, that is a literal blink of an eye. So the question hits us again, why aren't they here? Well, this exact mystery led to a really fascinating source paper by researchers Jacob Hawk-Misra and Seth Baum from Penn State. They proposed something they called the sustainability solution to the Fermi paradox, and it's a real game changer. They argue that throwing up our hands and concluding we're totally alone in the universe is jumping the gun. Instead, they suggest that the core assumption of the paradox we just talked about, that civilizations just blindly grow exponentially forever, is practically impossible on a galactic scale. Their theory essentially splits the cosmic fate of civilizations into two distinct paths. On one side, you have the faster growth civilizations. They expand exponentially, going as fast as they can, but just like we've seen on Earth, it's ultimately completely unsustainable. They consume resources way faster than those resources can be replenished, and eventually they burn out and collapse. On the flip side, you have slower growth civilizations. These guys manage their resources sustainably. That means they survive for an incredibly long time, but the catch is their expansion is so slow and cautious that they simply haven't made it all the way to our corner of the galaxy yet. And we don't even have to look out into space to see this dynamic. We can actually see it mirrored in human history right here on Earth. Just think about the historical collapse of Easter Island. You had rapid population growth, total resource depletion, and it led to a devastating, highly visible decline. Now, compare that to the Kung San people of the Kalahari Desert. They've maintained a sustainable, slower growth population for thousands and thousands of years. Both societies were highly intelligent, obviously, but they followed radically different trajectories when it came to expansion and managing what they had. So what's the takeaway here? The sustainability verdict tells us that the galaxy isn't necessarily empty. It's entirely possible that those aggressively expanding empires just collapsed too fast for us to ever notice them against the vast backdrop of cosmic time. Meanwhile, the sustainable, slower growth aliens are absolutely out there, just taking their time and growing too slowly to have bumped into our solar system. But it also opens up a pretty haunting possibility. Our galaxy might literally be dotted with post-collapse graveyard civilizations, just scattered ruins of societies that grew too fast and burned out. Okay, but what if resource collapse isn't the reason for the silence? What if the universe isn't a graveyard at all, but rather it's full of survivors who are just utterly terrified? This takes us to a totally different and honestly super chilling explanation for the Fermi Paradox, the dark forest hypothesis. Now, what's really interesting about this concept is how science fiction often ends up anticipating actual scientific theory. Take a look at this quote from Greg Bear's 1987 novel, The Forge of God. He describes the universe as a vicious jungle, where humanity is like an infant lost in the woods, crying its heart out, drawing down the wolves. Just think about that. We sit here on Earth, cheerfully blasting radio waves into space, scratching our heads wondering why no one is calling us back, completely oblivious to the fact that the galactic skies might be full of hawks just waiting for a foolish little bird to chirp. Literal chills, right? The actual term dark forest comes from the incredibly brilliant 2008 novel by Lou Sixon. In it, he introduces this idea of cosmic sociology, which is based on 3 pretty grim axioms or rules. 1, survival is the absolute, primary, non-negotiable need of any civilization. 2, civilizations will continuously try to expand over time. And 3, the total matter and resources in the universe are finite. They stay constant. When you put those 3 things together in a blender, the universe suddenly becomes an incredibly dangerous, cutthroat place. So the crucial point here is how this all plays out mathematically through game theory. Think of the universe as a sequential game of incomplete information. You can never, ever truly know the real intentions of an alien species you've just detected. Are they friendly? Are they hostile? You just don't know. And because survival is the only win condition and resources are highly scarce, a massive chain of suspicion forms. If you detect another civilization, the absolute safest, most coldly logical move to ensure your own survival is to launch a preemptive strike, destroy them before they even get the chance to destroy you. Under the logic of the dark forest theory, you basically end up with exactly 2 types of civilizations. On one hand, you have the dark forest-fearing civilizations. These guys understand the rules of the game. They might be completely benign, but because they want to survive, they stay absolutely perfectly quiet. They don't make a peep. On the other hand, you have broadcasting civilizations. The second they reveal themselves, they are immediately viewed as a highly unpredictable existential threat by those silent hunters lurking in the dark. And because of that, they are swiftly targeted and eliminated. So, whether this cosmic silence is caused by sustainable civilizations taking things incredibly slowly, graveyard civilizations that already collapsed, or terrified survivors hiding out in a dark forest, it completely and fundamentally changes how we need to be looking for them. For decades, the old SETI strategies relied on listening for loud, intentional radio broadcasts. We were waiting for a friendly hello. But newer strategies suggest we really need to pivot. We need to stop expecting them to shout and start looking for much more subtle clues, things like stealthy remote probes or the atmospheric scars of a collapsed world. One way we can actually do this is by searching for specific biosignatures on distant exoplanets. Because think about it, even if a civilization completely collapsed and lost all its radio technology thousands of years ago, or even if they're actively trying to hide from hunters, their planet might still breathe. We can use our telescopes to look for the presence of ozone and oxygen coupled with methane. We could search for anoxic, meaning totally oxygen-free atmospheres, similar to what a young Earth looked like. We could even look for something called the red edge of chlorophyll, which is the unique light signature given off by plant life. None of these markers rely on an alien wanting to talk to us, they just require them to exist.
And this brilliantly illustrates a much more pragmatic, close-to-home approach we're seeing gain traction: solar system SETI. Instead of scanning the vast, endless sky hoping to catch a stray radio signal, what if we just checked our own backyard? A sustainable, slow-growth civilization might not ever colonize us, but they might send out tiny, practically immortal messenger probes, maybe just 1 to 10 meters across. Researchers are suggesting we should rigorously search our own asteroid belt, or our Lagrange points, which are basically these gravitationally stable parking spots in our solar system, for hidden, dormant artifacts left behind by some ancient, slow-moving galactic explorer.
Ultimately, though, turning our gaze out into the deep cosmos forces us to look right back into the mirror. Whether it's the sustainability solution or the dark forest hypothesis, both ideas highlight a brutally critical concept for us right here on Earth: the need for sustainable development. If rapid, exponential growth always leads to collapse, then we absolutely have to figure out how to manage our own environmental impact, our population, and our resource consumption. If we don't transition to a sustainable model, we might not even survive long enough to have a chance at exploring the stars in the first place. Which leaves us with this final, profoundly heavy question to consider as we wrap up today's explainer. As our own global civilization continues to accelerate and advance, are we going to figure this out? Will we learn to manage our resources and actually sustain our society for the long haul? Or, by blindly continuing to expand and carelessly broadcast our presence out into the cosmic void, are we just going to remain that crying infant in the woods, drawing down the wolves? Thanks so much for exploring this deep dive with me today. Keep looking up and stay curious.